Dear professional students, let's look at another areas of quantitative analysis, and this is what we call statistics. So we have a subject matter of statistics here, and there are several concepts that usually characterize characteristics. So we are going to start with measures of location, or better still, we can call it measures of central tendency. So these words can be used interchangeably to mean the same thing. We can call it measures of location or measures of central tendency. So they are basically statistical measures, or they are those measures that are commonly used in statistics. And statistics here is one of the important concepts that underline the subject matter of quantitative analysis, or quantitative techniques as the case may be. So when we talk about a measure of location, like I said, it is otherwise known as a measure of central tendency. So as a matter of fact, it is commonly regarded as a single value, which is usually an average value of the variance, and this can be used for the purpose of describing the general level of the variance in any given statistical data. This is usually a single value, and this represents a given distribution in any statistics. So we have measurement of location, which we commonly call average values. That is, the measure of location are usually regarded as average values, and in many instances these particular values are being employed for the purpose of comparing distributions in various statistical values. So the commonly used measures of location or central tendency include the following. We have the arithmetic mean, we have the median, we have the mode, we have geometric mean, and we have what we call harmonic mean. So all these are important measures of central tendency. And when a statistical data is given, we may be required to carry out all these statistical measures in terms of computation, so as to get appropriate value that can really explain the data or statistics given. So the commonly used measures, once again, in statistics or central tendency are: we have the arithmetic mean, we have the median, we have the mode, we have geometric mean, and we have harmonic mean, among others. So let's look at each of these measures one after the other and see how they can be computed when given appropriate statistical data. So let's begin with arithmetic mean. We have arithmetic mean. When we talk about arithmetic mean in statistics, it is usually regarded as the average value. That is, any given statistical data that requires the computation of arithmetic mean, we simply need to compute the average value of such statistical data, and this is expected to be representative of a given homogeneous distribution during any given statistical process. So we have certain notations that are basically used to describe the arithmetic mean. So let an event produce the following n outcomes. Let's say we have x1, we have x2, we have x3, we have x4, x5, up to xn. So the xi represents any of the values such as x1, x2, x3, up to xn, and the letter j we have here is also standing for the numbers, which can also begin from 1, 2, 3, 4, 5 to n. So we have this as our symbol, which is summation xj, and this is used to denote the sum of the j's, which are 1, 2, 3 up to n, and likewise the n, which are also 1, 2, 3 to any number. So in other words, when we are trying to determine the arithmetic mean of any given statistical value, such as we have the x1, we have x2, we have x3, we have x4 up to xn. So the arithmetic mean is usually represented by bar x, and the formula is summation x all over n, which means the summation or the addition of all the x values given divided by the number of times the event or the observations occur. So for arithmetic mean to be computed given relevant statistical data, the formula is bar x, which is equals to summation x all over n. So like I said, the arithmetic mean is simply regarded as the average value of x, and it can be computed using this formula. We have bar x, which is equals to x1 plus x2 plus x3 up to xn all over n. So that is a simple formula we can use for the purpose of computing the arithmetic mean. So the x bar here represents the arithmetic mean or the average value, and the formula is x1 plus x2 plus x3 up to xn all over n. So like I told us here, n is equals to number of times the observations occur. Number of times the observations occur. Then we have the x1 to xn, which represents set of data from 1 to n. Then the x bar here represents the arithmetic mean, which is otherwise known as the average. So when we are talking about arithmetic mean, we are otherwise talking about average. So anytime we want to compute arithmetic mean, then this formula is expected to be sufficiently used. So let's look at the example here and see how we can demonstrate the formula we have provided for arithmetic mean. The question says, calculate the arithmetic mean of the following amount of money, which represent the expenses in naira of 10 students on food on a certain day. Let me take that again. Calculate the arithmetic mean of the following amount of money, which represent the expenses in naira of 10 students on food on a certain day. We have 70, 65, 73, 105, 85, 90, 69, 95, 82, and 100. So based on this data, we are majorly required to compute the arithmetic mean. So to do this, we can let x represent all these. We have 70, we have 65, we have 73, we have 105, we have 85, we have 90, we have 69, we have 95, we have 82, and we have 100. So to now compute arithmetic mean, which is summation x over n, then we have to put all this in addition form. That will give us 70 plus 65 plus 73 plus 105 plus 85 plus 90 plus 69 plus 95 plus 82 plus 100 all over n. N number of times observations occur: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all over 10. So we now have our bar x. So let's now sum all this together. So we have 70 plus 65 plus 73 plus 105 plus 85 plus 90 plus 69 plus 95 plus 82 plus 100. This is equal to 834. We have 834 all over 10, and this will give us 83.4. Therefore, the arithmetic mean in terms of expenditure will be equal to 83 naira 40 kobo. So that is the arithmetic mean on that particular expenditure as incurred by a total number of 10 students on food on a certain day. So let's look at example 2. The one we have just done now, you can see that it is just a given set of data, and as a matter of fact, it does not include any form of frequency. So in many instances, we may have to deal with a set of data that involves frequency. So if we have that, then our arithmetic mean formula will change to summation fx all over summation f. So that is with frequency. Data with frequency. If we have data with frequency, then our formula for arithmetic mean will definitely change to summation fx all over summation f. And when you talk of summation fx, don't forget we have the product of f and x. The f represents the frequency. F represents the frequency and the x represents the set of data given, which could also be in form of class, interval, or what have you. We are still coming to that. So x in this case could simply represent a mere set of data. So based on this question now, you can see that we have frequency. The number of students here represents frequency. So as a matter of fact, we are not going to deal with it the way we have dealt with the previous example. And because of the fact that it included frequency, then the formula has actually changed to summation fx all over summation f. So let's look at this question. In an examination involving 36 students in a class, marks were scored as follows. We have the score in percentage, and they include 40, 50, 60, 70, 80, and 90. On the other hand, we have the following number of students taking the respective scores. We have 9, we have 7, we have 6, we have 6, we have 5, and we have 5. So the implication of this is that for a total score of 40%, 9 students got 40%. For 50%, 7 students got 50%. For 60%, 6 students got that. 70%, 6 students got that. 80%, 5 students got that. 90%, 5 students also got that. So based on that, we are required to calculate the average score for the class. Calculate the average score for the class. So to do this, it is always convenient to present our solution of this type in a tabular form so as to be able to achieve clarity and accuracy. So we have this. The score can represent our x, and based on what is given to us, we have 40, 50, 60, 70, 80, 90. Then we have the number of students which represent the frequency. So we have 9, we have 7, we have 6, we have 6, we have 5, we have 5. So let's now go for fx, column fx, and by column fx, that will give us f times x. So we have 40 times 9. This will give us 360. We have 50 times 7, that's 350. We have 60 times 6, 360. 70 times 6, that's 420. We have 80 times 5, that's 400. Then we have 90 times 5. We have 90 times 5, 450. 90 times 5, we have it as 450. So let's sum up our fx and f together. So we have 360 plus 350 plus 360 plus 420 plus 400 plus 450, and this is equals to 2340. And let's add our summation f. We have 9 plus 7 plus 6 plus 6 plus 5 plus 5. This is 38. We have it as 38. But in this question they told us 36 students. Then there is a problem. If that is the case, maybe one of these should have been 3. One of these should have been 3, but we can change it to 38. That could be a problem from them. So we have this as 38. But what is important is we need to get our act in order. We have to make sure that we leave no stone unturned in getting the appropriate values. So based on this, we can have our bar x, which is the arithmetic mean, to be summation fx over summation f, and that will be 2340 all over 38.